for me, this particular subject, I think I was probably a bit of a late convert into the interest of this. And it started for me last year at COP27. So for those of you who were there last year, it was in Sharm el Sheikh, and pretty much the only way to get around was by very small, very fast, and quite dangerous taxis. And there weren't very many of them around either. So every morning when you came out of your hotel, you stood on the road waiting for one of these taxis, and because there weren't many around, you had to share the taxi, and it was a real lottery of who you got. And sometimes it would be a world leader. On this particular day, when I got in the taxi, it was a protester with a banner, war paint. He had long hair, torn jeans, the lot, and. As we sort of tore down the road at breakneck speed, he looked at me and he said, "Okay, so what is it you do?" And I quite proudly said, "Well, I work for an international engineering firm. You know, we develop infrastructure, metros, hotels, all of that." And he looked at me, and he was sitting next to me, and he pointed at me, and I've done my best to actually give you a quote of exactly what he said to me. "You are one of the problems. Your industry continues to talk about the decarbonisation, yet it fails to grasp the real problem, which is carbon generated by manufacture of steel and concrete. You are worse than the oil companies because at least they realise they have a problem." Sitting, so as we sort of rattled down the road, I thought, and all I could say to this particular individual, whose name I have to say I can't remember, let's call him Joe, was that actually you are dead right. And from that moment, I felt that our industry really needed to take accountability of this problem. Well, the taxi came to an end. He rushed off to join his friends to yell at people as I went into the next session. The next session was run by John Kerry, and he runs this this group called the First Movers Coalition. And so what it is basically a bunch of very large companies that commit to changing the world through positive climate practices. And this subject came up, the subject of green concrete. And he put it to the assembled CEOs of these large companies. And they committed to what I thought was a pretty unambitious 10% of green concrete, not green cement, green concrete by 2030. This will make absolutely no difference at all. It is a drop in the ocean. And I came out of that and I thought to myself, well, if I could actually find our friend Joe again, then I would probably shake him by the hand and said, actually, you're dead right. We've got to do something about this. So a very long-winded way of introducing this subject, but I was really pleased to be the moderator for it because I think it's for me now it is something that is a real personal passion of mine. I've got a number of questions. I'm going to go really through the context of the problem. I'm going to be looking at also some of the solutions and how we can hopefully go out of this room a little bit better educated about it and at a better idea of what to do. First question, however, I am going to turn to Tina and say, was he right? Is in the context of decarbonising infrastructure, is concrete the problem?
Is this working? No, hold on. Hello. I must be doing something wrong. Okay. The answer, Chris, to your question and Joe's summation is he was dead right. And why was he dead right? Because if we look at carbon emissions and embodied emissions in our sector, we have largely, most of them are focused in iron, steel, aluminum, and cement for buildings. Of course, there are other materials, but those will be the bulk of what's creating our embodied emissions. And that's about 15% of global emissions worldwide, just what we put into our buildings. So about half of that 15% is cement, and the other half is the metals. Metals are used by lots of other industries, all sorts of manufacturing, cars, and other manufactured products use iron, steel, and aluminum. And they all have a role to play in decarbonizing their supply chains and their manufacturing. But cement is special. We, in the building and infrastructure sector, are the only ones to use cement. It's only our industry that can actually find a solution. And we can't reach net zero if we don't address that significant part of our conundrum. So I would say, first of all, it's a huge problem, and we'll talk about the size of it. I mean, if you look at like an individual contracting firm, and we just happen to have one RICS member firm who has submitted a project for our COP28 showcase, and they are looking to reduce their footprint of cement. But they calculated, this is Lang O'Rourke from Australia, calculated that 60% of their carbon footprint was from cement alone. So we're talking about a major part of each of our industry's players. And the other thing you need to keep in mind is that cement, today, the sort of default way of treating cement when it comes to the end of its life is to crush it up and use it as infill, roadways, bedding of roadways, berms, etc. You know, it's very, very low value. We've destroyed the value, and we've destroyed that use of carbon. It's just basically been pulverized and used in a very low-grade manner. And the way that we use our default end-of-life values for concrete show that in situ concrete, which has been casted in situ, 97.5% of that is crushed and used as aggregate, or not even aggregate, landfill. Backfill, infill. And then 2.5% landfill. And for precast, it's only slightly better, 96.5%. And, you know, which actually goes into recycling. And I find that amazing. And I am going to let you know that I've been looking into why that number is so low. It seems to me if you have a precast concrete structure or facade panel, that could be demounted and reused. I don't see why not. And I think it's simply because that's not the way we do business today. It's a lot easier just to tear everything up, bring in a few big wrecking balls, pulverize everything, and then, you know, shift it over to backfill a roadway or berm. Because I was looking at a Swiss study on something called PRECS, P-R-E-C-S, which is short, the acronym for Piecewise Reuse of Extracted Concrete in New Structures. And actually, it's really interesting. There's over 75 cases that they have managed through this, you know, École Polytechnique in Lausanne has managed to find 75 use cases of places where concrete, in situ concrete, as well as precast, but in situ especially, has been cut out of a building and gainfully reused on another building as a concrete slab or a concrete brick or whatever it is. So it can be done, but we're not doing it. So that's one sort of way. And then just quickly, I'm not going to take too much longer, is, you know, we obviously need to use less cement, and the cement needs to be lower carbon. So there's two parts to that. Using less cement means we could be designing more efficiently. And that's where whole life carbon cycle assessment comes in. You can design with less cement, less concrete, and be just as structurally effective. A lot of times our structures are over-designed simply because it's quote-unquote safer. But that probably is a design practice that needs to stop. And then the other route is that our cement could be lower carbon. And how could we decarbonize cement production? And we have specialists on the panel, so I'm not going to go too much into that, but there are cement works that are looking to add hydrogen into their fuel mix. There are others that have actually, trialed new cement mix for piling works, and quite successfully so. So there are ways. But to get back to the question, this is a solution that we need to find in our sector because we're the only ones who can do it.
Yeah, and you picked up a good point there also, that the one of the problems of the construction industry, it doesn't change very fast, and so what we're looking at here, some of the solutions may require quite significant change, and so I think we're going to have that challenge as well. But let's just, as I said, this is supposed to be a bit of an educational journey. Let's just go back to what the problem is, and I'm going to turn to Fad for this particular one. In terms of the way that cement is made in its traditional form, what is the problem with it? In terms of how is it that as I said, we're all pretty familiar with a ton of cement is a ton of carbon. How can it be that much?
First, I'm a concrete person. So I'm going to push back a little bit if you let me.
Fine, go ahead. And you said you talked in bullet points as well, so I'm happy with that.
I'll do it in a nice way.
I can help you.
Let's go back to a little bit larger picture. 90% of the carbon footprint of concrete is cement, and that is, and 95% of that is clinker, which is a precursor to cement in the manufacturing process. And as you said, 1 ton of cement is approximately, just for ease of calculation, let's call it 1 ton of CO2. And oddly enough, cement and concrete are among the lowest carbon footprint construction materials that we have. If you compare it to virgin steel, it's 3 times more. Cement to steel, if you compare it to virgin aluminum, it's 10 times more. But cement is a victim of its own success. We use so much of it. It's so local, so inexpensive. It's flood resistant, it's hurricane resistant, it's fire resistant, and it's cheap and it's moldable. So that's the positive side taken care of. So we use of it, and I have my cheat sheet here. We used 1.4 billion tons in 95 of cement in the world. Jumped up to 2.3 billion tons in 2005, 4.1 billion tons in 2015. The good news, it's plateauing. We're at 4.2, 4.3 billion tons until in the foreseeable future, until 2030 at least. So from a usage side, we're there. We're not adding as much as we were before. And most of that ramp came from the industrialization and the urbanization of China. China was using more cement every 3 years than the US used in 100 years. Every 3 years since 2005 maybe. That's slowing down. It's being replaced by Africa and by India. So to go back to where does the CO2 come from? The clinker, which is the precursor phase of the cement, comes from heating up of limestone, which is a calcium carbonate at 1450 degrees centigrade, which is a lot of heat. It's a fifth of the third of the temperature at the surface of the sun. When I heard that, I did not believe it. I had to go back and check it. Surface of the sun is 5,000 degrees. We're heating cement or limestone to 1450 degrees. So when you heat calcium carbonate, it breaks down chemically into calcium oxides and CO2. So we exhaust, depending on the fuel that we use, we exhaust either 1-to-1, so 500 kilos of CO2 in the air to produce 500 kilos or another 500 kilos of raw material that we have left over, or a third, 2/3. If you're using a cleaner fuel, you're exhausting a third, like 330 kilos. If you're using a dirty fuel, you're exhausting 500 of that. How do we work? How do we reduce that? We're looking at 3 major ways. One is cleaning up of the fuels and the electricity that goes into grinding of cements. 2, we're looking at changing the chemistry of cements, maybe not using the same raw materials, but that gives you a different cement. How do you use that in existing Or the third and most controversial approach is carbon capture and usage from post-industrial, if you like. And that's another big discussion.
So in other words, abating the, just staying with the process and just abating it.
It looks like the only way to decarbonize cement as we know it now completely.
Interesting. So let's, and that is a really good subject, which we should come back to. But I was quite interested in those new solutions. So we've definitely, as Tina mentioned, it's a problem in terms of decarbonising infrastructure. You've just described the fact that it is a big problem. It emits a lot of carbon dioxide in terms of the in terms of the scale of the products it's used in construction. So what about some of those alternatives? I'll turn to you, Gabriella, because it's not just about maybe finding replacement cement. It's maybe also there are alternatives for masonry, for example. We don't have to use concrete for everything. So maybe you can just talk about some of those. And actually, how scalable are they? Because this is one of the problems, is actually not just finding the technological solution, it's actually how do we scale it into the industry?
So I'm gonna start giving a bit of my background before anything here. So I develop sustainable building materials. I don't allow cement to enter in my lab, to have an idea, because I think that the solution that we need, I'm a civil engineer, and the solutions that we need to deliver at the pace that is needed, we need alternative materials too. And the problem, I think the cement is the big elephant in the room that we have, and we need to be thinking big. We need to be ambitious here of how we're going to deliver that. And in terms of alternative materials, I'm going to give the example of bricks. That fire clay bricks require temperatures for firing between 1,300 and 1,700 degrees Celsius. Very energy intense. And at the same time, they are very dependent of natural resources. They depend on clays. We have been developing materials that don't depend on natural resources. We have the K brick. I don't know if you have been on upstairs in Clean Tech, that we have a wall with the K brick. So I'm the inventor of the K brick. And we use for that construction demolition waste. It is made of construction and demolition waste. And there is no firing for the K brick. As a consequence, is a reduction of 95% of the carbon in comparison to fire clay bricks, and will be with concrete. So it's a massive reduction in the emissions, it's a massive reduction in the energy required, and the material is out there. And we have been testing for facade use, that the manufacturing is in the UK, and the reality of the UK is a lot of use of bricks for facade in particular, and have been tested for all the standards and is compatible in terms of performance and weather response. But one big challenge and a big question that I'm being asked very often is scalability. And the first thing that comes to mind is the material. So if I'm going to replace, let's say, the fire clay bricks that are out there today with the reality of the UK, that is one of the largest market for bricks, that is 2.6 billion bricks used per year, can we do it? And we can. I don't have the manufacturing capacity scaling up yet, but we can in terms of the materials, because the UK alone produce over 100 million tons of construction demolition waste per year. And if we wanted to produce the 2.6 billion bricks that we use in the UK, and over 500 million tons of those bricks are imported, again, crazy to think the carbon that it is to move these heavy materials, but they are imported. We could manufacture. So I think we need to be ambitious. I think the targets that we need to meet for a net zero economy are out there, and we know from what we see the temperatures, the extreme weather that we are observing in so many parts of the world. We know that we need solutions that can be delivered at pace and now. And I think we need to join forces to see how can we, as a construction industry, as a materials industry, can look at alternatives that can deliver this with the impact that is going to make a difference and with the pace that we need. Because we need all together. We cannot just have one thing. We need to have all the solutions together, and we need, and this is something that probably we have lacked and is our fault as a sector. We are not communicating enough. We need that to have solutions developed and implemented at the required place.
And that, I think that probably also comes back to something that Dr. Adel, and I will come to you next, actually, because you mentioned it during the last session. Was that something that, particularly in this region, we're not very good at doing is getting industry to work with academia, and you were talking about it in the last session. Just before we get into that, the existing codes and regulation that we now have, how do they encourage the new products that, for example, Gabriela was talking about and Fahd was mentioning in terms of alternatives to concrete? How do they address the problem, or do we actually need new regulation and codes?
Right. Good afternoon, everybody. Thank you for this question. But before this question, perhaps I will go for some notes. One of them about, you asked a question about the maybe from where the cement is made, I mean, the kind of materials which made the cement. Before that, I have something learned from history. Right, I was living in Scotland before when I started my PhD, and I worked in university in Glasgow, and that's why my pendle here shows that it is Scotland. Now, I would like to ask a simple question to the audience and maybe the panelists as well. What is Scotland famous in? In buildings. Let's make it in particular in building. What are the most kind of famous things in Scotland?
Whiskey.
Question, especially to the British
Whiskey.
people. What is it?
Whiskey.
Huh?
Distilleries.
Whiskey?
Yeah.
I said building.
Distilleries.
Castle, well done, castles, okay? Why I am saying that, okay? Because when I was there as one of the team at Paisley University that time, next to Glasgow, we had a very strong team led by Professor Peter Bartos. When there is kind of will, there is way. It comes to us that some of the castles, very beautiful castles, it requires some kind of repair and maintenance. And then the only things we thought about that time, especially my mentor that time, the Professor Peter Bartos, and we are in his team, he said we have to come out with mortar which can fit the castle 100 years ago. The same mortar, we cannot put any mortar which is of nowadays, and we are going to repair this castle. We have to go back in the history to see what mortar they did before. We are going to make it now. And we get very big grant. So that is, again, from the government. And we built a kiln, and we made a special kind of mortar specifically for the castle. So it means, even with the cement, this thing, it made me learn a lot of things. At that time, we were talking about the concrete as high-performance concrete. I came from UK to here, and we are calling concrete high-performance concrete. After a while, they changed it to sustainable concrete. It's the same thing. It is mentioned high-performance concrete. We studied this before. We teach it. This is 1990, 1991. I was teaching that time. It's called high-performance concrete. When I came here in 2000, after 5 years, or maybe 10 years, they changed the title. This is the same concrete, high-performance concrete. Now we call it sustainable concrete. Now I made a course Now I'm teaching course at the American University of Sharjah called Design of Sustainable Concrete. Design of Sustainable Concrete. So we change it. But it's the same thing. It is how to reduce the amount of cement or the concrete, in fact, the concrete, not only the cement, the aggregate, the whole things, to reduce the size of the structure to make columns or beams with smaller cross sections, with high strength and durable. Okay, life cycle is very important. So all these things it can be done. In university, we have the kitchen, let's say our kitchen, the recipe about the cement. We know what's the cement. Cement is lime, silicate, aluminate, okay, and sometimes forgotten alkali. Alkali is small amount in the cement, maybe 5%, but it makes the big things. In our university, what we did, we replaced the cement with materials. It has silicate, it has aluminate, but doesn't have alkali. Alkali, it comes from the cement. So we took away the cement away, we take it away, and we brought just alkali, which is sodium hydroxide, kind of liquid, and we added to waste material, and we made cement. So if there is will, there is way we can do things. And we did a concrete called geopolymer, as you know, and we apply this as a patent now because it's new way from international ways. Now, about the code, your questions about the code, most of the code is about strength. Recently, they changed it to durability. So, for example, the ACI code 318 now, a few years back, they put more in durability. So that is some kind of advancement. We are now going more to durable and more surface type. But we need to have more kind of codes. There's no more code in environmental force. Back to, for example, UAE. In UAE, the environmental agency in UAE, they set some kind of target to all cement factories here in the Emirate to reduce the fuel by using 10% waste fuel. That was back in 2021. So these kind of things, it is kind of regulation.
So from I think what you're saying is it's not the problem with the code. It's just a problem for us to express these new materials to actually fit the codes that we have.
Exactly. So it means we can do it ourselves.
And which actually brings us neatly on to Chris. So I'm going to Chris. I'm going to place you in the if you like in the client's corner here. You're working in Masdar and you are using some of these products. So from a client's perspective, how are you using them? Are you seeing any cost benefit, cost disbenefit? How does it actually work in a real development? Because you're using them. I've seen them with my own eyes. So tell us about that.
Hi everyone. So yes, as you say, I'm representing the end user. I'm out of my depths here. I'm no concrete expert, not the way you talk about it. I've come across, I'm in the receiving end, and many people come to us with many different ideas of alternatives and things that we might try out at Masdar City in our role as building a sustainable city. Oh, and by the way, oftentimes when we talk to our architects and engineers, we say sustainable city, think about it as high performance buildings, right? Then you get that metric coming in. And so anyway, as an aside, embodied carbon, which is where we start from, Masdar City has been measuring its embodied carbon since our very first buildings. And so that has given us a checked history and understanding of use of materials and in our buildings. We have different construction systems and they sprout out very different numbers. I must admit that the the database that we're using is not what you find in softwares today, because 15 years ago these softwares were not around. We use a UK-based system, actually from University of Bath, is where we looked at, which is actually where I came from myself. And when we looked at that, our methodology, let me explain, our methodology for measuring is very, very simple in those days, and we haven't moved away from it because baselines are still an issue. Correct methodology is still an issue. I think Farah from Alpine before was saying you don't know what you're measuring. Is it money based or quantity based and this kind of thing? So we stuck to our old system because what we wanted to do was compare against a common baseline, which is the one we use. So we were comparing from building to building, and we have over a dozen buildings of different nature to guide us. And so clearly in that, concrete was the highest number, right? In the early days, steel was actually higher, and we like to talk numbers in terms of kilograms of CO2 per square meter of construction. In our whole history, we only had one building that exceeded 1,000 kilograms of CO2 per square meter, and that was a steel structured building, right? Didn't do that again after that because we moved away from steel and we actually went to concrete because it was lower. Now, it's still high, but lower. But then how do you go from there? I think there are two things that we did from an end user point of view, and my background is an architect, by the way, so I'm not an engineer, I'm not a numbers person, but I'll talk it from an architecture point of view. The role of architects, role of design, and you mentioned it, Chris, is about the way we design. So we did forms of life cycle costing, forms of life cycle assessment, and we took every one of our projects based on the end user's need. We looked at grids and types of slabs, and we kind of compared all of them and see what gave us effectively the lowest quantity, which then translate into lowest carbon footprint to do its job, right? And so we were using the embodied carbon as a first parameter to get into the details rather than measure it afterwards. And that's how we gradually managed to understand and improve our buildings. And by the way, our current buildings are well below 600 now and moving towards 500. And I understand from people like Arup, they're saying the global average is probably around 800. Until I hear better numbers, that's what we kind of use as a baseline. So we keep pushing ahead. So that's one side about efficient design. Again, high performance design is where it comes from. We're being efficient use of your structure, right? We're really boring. We're trying to move away from cantilevers, for example. I mean, there are things in structure dynamics that you do. We're really, really about everyday architecture. And at the end of the day, 99.9% of buildings are regular vernacular architecture. So that's kind of our space to deal with where it counts. Then there are what we do with cement. We have looked into it and have used the traditional cement replacements. Our standard specifications calls for either fly ash or GGBS, this type of thing as a standard. We know that's a kind of first move. I understand that there are supply chain challenges. We've even cement replacement today, so that's also challenging. And this is all in the context Masdar City is a wholly owned subsidiary of the Mubadala Investment Company, right? And it's the middle word, investment company, right? It's not Mubadala charity or Mubadala giveaway. And therefore, the investment benchmark for all our buildings, right, which started off as LEED Platinum 12 years ago, and now we are actually delivering net zero energy buildings in operation, but all of them are competing in the open market for tenants, right? So they're financially viable, and that's where we are in our learning. Net zero energy in operation. We haven't got the net zero carbon yet, or the embodied carbon. That is work in progress. So that meant that the way we look at the financial side of this is really, really important, right? And that's where that's where we are at the moment. We are looking for alternatives, and we are talking to many people. Someone came to us the other day and said, "Look, we're using magnesium, magnesium oxide, and carbon absorption, etc., etc." But
that's really quite interesting. So do you think? So I suppose two questions completely different. First of all, are you finding consultants coming to you with these suggestions of alternatives? For start.
Yes, we are.
Okay.
Consultants are coming with alternatives. And this is where it comes to the policies and regulation part, because we have in the real world budgets and timelines, and we always say, yes, let's approach authorities, let's talk. It's kind of unfortunate, many a times good ideas stops in the tracks when we talk to regulatory bodies and there's questions about health and safety. I'm not saying that's always the case. Another thing I'm finding is that contractors, there are now more and more like-minded contractors who themselves are proposing alternatives and willing, and even just to be on their, let's say, ESG roadmap, right, and not essentially looking at the bottom line or giving up some part of the bottom line to experiment in something new and being first mover. I'm seeing that happening is very optimistic, but we continue to face barriers.
Yeah, and I think that's an interesting point, because many coming from contractors, I've sat with a number, and all of them pretty much have said we would be completely happy if the government mandated the use of green cement. Completely happy, because it's just a commodity. It's a commodity cost, so everybody gets treated the same. And from what I'm hearing, you would just support that as any developer would.
That's right. Our standard specification is the so-called green cement.
Yeah.
Right, with some form of cement replacement. That's our standard. And the way that we pay for it is going back to high performance design, because we do our utmost to use less material for the given job. Right? And when you compare to business as usual, it means a savings, which we do not give back to our budget team. We keep it and we put it into other areas, right? In this case, if there's any uplift in cement replacement, or when you go over past that, then it goes into insulation or better mechanical equipment, just to improve the performance. We're in a world where we expect designers to also design with numbers. Maybe that's a tall order, but that's the space we're in.
And I think that's also been quite. I think it's quite insightful for the audience as well, because there are, as I'm sure you know, and Claire, you mentioned it to me as well, is that many people, probably in the UAE, think that Masdar is maybe this laboratory which works out the greenest way of doing something, just demonstrates it can be built. But our developers, full-on developers, and it has to work from a commercial perspective.
Mr. Chairman, sorry, can I have 30 seconds?
You can have 30 seconds, Mr. Adam.
Because
Please
I
go
feel I didn't finish why we use lime for old castle. What's the reason behind that? Because we wanted to make lime which can integrate with the old things. At the same time, it does not make any kind of differences in kind of aesthetic or discoloration. So it becomes best fit, and it integrate with the old stuff, and it becomes stronger. So it doesn't show any kind of new repair, as if it is old, 100 years old.
And it's being a castle, it certainly stood the test of time.
Yes.
In terms of durability. Fad, coming to you, if you got any other examples, probably in the region actually, where this green concrete technology has been deployed, and are you seeing it increasing, or is it too slow?
The UAE has been an open air lab when it comes to low carbon concrete, not cement. The cement industry is one of the slow movers. The construction industry is a slow mover, and cement industry is a slow mover because of the capital investment they have. They don't like to change things, how they do things. But in the UAE here, starting back, I don't know, maybe 25 years ago with ADNOC, we started using low cement concrete, with the cement replacements. Then came local regulations. We started with the Estidama in Abu Dhabi. Estidama as a scheme is mandatory. It's a point system. You can get your points from different categories, and with concrete you can get 2 points. If you reduce your cement content in your concrete, you can get 1 point or 2 points, which was an easy win for somebody running after points in that scheme. Then Dubai came with Saafat, which was more of an operational carbon, but had a small embodied carbon. That was followed up by the Dubai municipality circular for green and sustainable concrete. And that gave a big push in the Dubai market. If you look at it on aggregate, concrete produced in the UAE has a 50% cement replacement, which doesn't happen anywhere in the world on aggregate. So our concrete is a lot greener than our cement. If you look at cement, no, we have a very high carbon intensity. We're in the 900s, 925, maybe 950. The best is around 875 kilos. If you buy a ton of cement in Europe, you're probably in the 650s. If you buy advanced or newer cements, CEM2s and high replacement, you can go down to the 500s. We do it on the concrete side here, not on the cement side. And
so how would we move? But at some point, the cement industry here has to change. So how does it do that? Would it? I mean, it's clearly going to take investment, but that investment would happen if the government regulated, wouldn't it?
The cement industry here now is surviving on exports.
Yeah, it is.
We have
That's right.
three times more production
right.
than consumption. One of the export markets is closing very soon because of carbon borders. So even if it's not regulated here, other regulations is going
exactly.
to
And
to
so
push.
and so it will happen. Otherwise, the cement industry here will die.
The problem is the solution doesn't exist yet.
Which goes back to
To
what we were saying.
decarbonize cement completely, we don't have a solution.
No.
We can reduce carbon footprint of cement.
But but then it's a different substance, isn't it? So I suppose that was really what I was getting
It's
to.
the same thing. What we're putting in our concrete to reduce Portland cement, they can put it at the factory. It's who accounts for it, who gets the.
But would it not be a different factory though? Because that process, the substitutes that
No,
are
it
used,
can be done. It can be done in existing.
it can be done in this existing.
Unless you
factories.
go to the newer chemistries.
Yeah.
The most successful different chemistry cement now is something called LC3.
Yes, that's right. Yeah, I've come across that. Yeah,
Cement.
that's right. Yes.
And that's supposed to reduce a ton of cement. Let's call it cement still. A ton of LC3 carbon footprint has a 40% lower carbon footprint because it's calcining clay, which has a lower temperature need than limestone. But then again, scaling it up to 4 billion tons is going to require a long time. One project that we did, you asked me about how we apply these things. One project that we did a few years ago in Abu Dhabi, we applied many levers to reduce the carbon footprint of concrete, not cement. We went back to efficient design by feeding back actual strength from actual concrete on the site back into the design, reducing the size of elements, reducing the weight of structures. We used cement replacements up to 50%. Using the Masdar calculator, we over 2 million cubic meters of concrete, we reduced the total carbon emissions by 300,000 tons of CO2. We reduced waste by managing the concrete supply chain differently within the project by 1%. So there's so many things you can do.
So I think what you're saying is that the solutions are out there. It seems that there needs to be more industry and government movement to actually make them happen a little bit more effectively. I'm going to come out for some questions from the audience in a moment. I'll just get one question actually for Gabriella, something that quite a few people have asked me, and that is around the ability of concrete, and there is a lot of it out there, to actually absorb carbon dioxide out of the atmosphere. Maybe you just want to give everybody a 90-second lesson on how that happens.
Interesting you asking me this. First, I think policy needs to be driving. There is no way industry is going to change what they are doing if there is no drive, that there is no push.
I would agree with that too.
Yeah. So I have been involved. I have a fellowship with Scottish Water that I look at their infrastructure portfolio, how to reduce carbon emissions. And we have been undertaking some trials with 2 different technologies. One of them actually is in the audience here today, to inject carbon in the concrete.
Yep.
And we've been doing trials. It does work, but the reduction is still too small. The thing is that we need more.
Yeah.
We need, needs to evolve. We need And that's why we need investment on that. It's great to see this. It's great to see that there is these technologies and they are evolving fast. But for us to have solutions that are going to be delivering at the pace that is needed, and we need more. We need much more than that, because it's not enough.
Yeah, good. That's a. I'd like that point as well. I think the policy and investment. Most people are of the same view that in order to crack this nut, that's what's going to be needed. Any questions from anybody before I go around for a last? There's one here.
Chris, at the beginning of this session, you'd mentioned it's a little bit of a smaller session, so let's try and make it a bit more of a learning session. So a bit of a selfish question from me. Just I want some takeaways just for myself. I deal with a lot of clients within the market, some very sophisticated, some not so. Are there any key specific points that I can take away today and start communicating to clients either on what they should be doing or what they shouldn't be doing? So for an example, what I got from Chris was, yes, use green cement. Perfect, I can take that away. What I got from Miss Gabriella was, avoid using fire clay bricks. Is there anything else that the panel can add that I can take away and start communicating to clients
That's a
straight
great
away?
question, Andrew. You've just, Gabriella, do you want to go?
I can start because I've been looking some statistics preparing for COP from the region. So 5,000 tons of waste from construction demolition in UAE is produced daily. And 70% of the all waste by weight produced in UAE is coming from construction. So it needs straight away is more waste management, because it needs to become more resource efficient. So first step, waste management, I will say, and is an easy one to be implemented and can make a big difference. And one thing that we talk all here and talking about concrete is, should we question ourselves and start thinking that we use more recycled aggregates to become more, because to me, it hurts my ears every time that I hear green cement, to be honest, because it's not cement then. What we
I would agree. Do you think it needs a different name?
I think it needs a different
I do
naming,
too. I
because
agree
it's
with
not cement, because the cement is not green. To me, it goes as basic as that. We need to be thinking, maybe we're developing other things, fantastic. And but we need to be very clear, because the danger here, and is the danger that we're seeing going back and back, and is that we start calling green things, and then you just add the green because you have a percentage that is 2%,
this is a
and it's
great
dangerous.
theme, this, Gabriel. So let's just come back to that. But
Yeah.
in answer to Andrew's question, your answer would be manage waste, use waste.
Yes.
Yeah.
Better waste management, reduce and reuse. I think that is used, because if you reduce the 70% here locally, is going to be a big benefit, and at the same time reuse when possible.
And Chris, you put your hand up.
Hello. We went on our own journey on construction waste at Mazda City. It's started 12, 13 years ago. And I think we locally produced a waste recycling yard within our construction area. And we offered to the contractors working with us that we would take away all their construction waste free of charge. And in return, they gave us a discount on the cost of the construction. Little did they know that we were taking their construction waste, and we built up a supply chain and started selling it. Right? And 2015 to 2016 thereabouts was the first year when the contractor refused to give us their waste.
That's a great story.
Right? And we still have that recycling yard there. You know, it's morphed over time depending on the user's needs. And back to your takeaway, we specify minimum 70% diversion from landfill for construction waste, and people are achieving that now in Abu Dhabi, especially in the project we're working on, and taking advantage of it, of using that supply chain. So I think as an owner representative, there's a lot we can do. And if you're talking to your clients, your developers, that look, you start from somewhere. right? But after a while, it makes sense, and then the economics follow it, and we've do that many times. Similar story. Now I just want to move away from concrete a little bit. Aluminium or aluminum, right? We put aluminium on a restricted material list more than 10 years ago. And for some strange reason, a couple of aluminium producers came to us and were extremely upset with us, right? I couldn't understand why. They said, you're such an energy-intensive producer, so banned. After we got over the animosity, right? They said, well, how can we fix this? So, well, there are many other parts of the world already using recycled aluminium, right? And so they worked on this, and that's where the availability of recycled aluminium came into Abu Dhabi, right? And so the 80% recycled content, 90% recycled content, one for extrusion, one for sheets, did not exist when I started working here. But then I'm just saying, working with clients and sort of sharing stories, how we can push, and there's the pull. Right.
Yeah.
And
so that's a good. I like that aluminium story. Fad, you had a point just to finish off the answer to that question.
Construction demolition waste. Dubai is pushing to zero landfill by 2028.
That's right.
And they're managing this by gate fees. They're going up
Yep.
every year between now and 2028. So by 28, zero goes to landfill. So there's now a lot of research being done on recycling it back into concrete, either back in the cement factories or into crushed concrete to go into aggregates.
I'd just like to add
Go on, finish it
one
off,
short
Lily,
thing.
yes.
I think what Gabriella said is key to it. Recycling is fine. It's better than going to landfill, but it's not better than reuse. Reuse is in the pyramid of value. We really need to try to reuse as much as we can. And that is going to be key, because the waste of our sector is huge. And I think, we can do as much as we want in recycling or diverting from landfill. Diverting from landfill means, in most cases, crushing up the concrete waste and using it to grade roadways or berms. It's very low value.
I think your answer to your question is you've got to tell your clients to manage their waste. That's clearly it. One more. Is there one question? One more question there. Yeah. There's a microphone behind you.
If you're building roads, don't you need aggregate? I mean, it might be low value, but it's something. It's got to be. Otherwise, you're going to be blowing out more bits of Ras Al Khaimah to put in your roads. And on the reuse of concrete,
Gabriel,
so I'm really amateur here, but on the reuse of concrete, how about the lifetime of the concrete? Thinking about the current issue we've got in the UK on concrete, we call them girders. But is there a problem in reuse in that sense, in that there's a lifetime limit?
There are standards for what is in the UK in particular. I don't know the standards here. What are the applications that are allowed to use with recycled aggregate, and the key things are actually, depending of the concrete application is allowed. The key thing actually is to be far from the groundwater, because of potential contamination. But if it's still, so when we reuse for road filler, is very low added value, and that's a problem that we have. We need to have circular approaches here that add value. Otherwise, recycling is the economic, to make economic viable, is to make the whole cycle. There is taxations in the UK for taking from landfill. For many years we have that, and this is a discussion that happened for many years. And there is more and more now discussion. I sit in some committees in the UK on policy for the discussion of use of raw materials. So if we start thinking that, I remember many years ago, the discussion that we'll start the landfill tax, and we have now implemented, and this is out there. Now the discussion is the tax on use of natural resources. So there is going to be a tax for use a raw aggregate, and then you're going to have the option to use the recycle aggregate. So you need to have more push like this from the government to have then the solutions in place.
And just a final question, Nikki, you had your hand up at the back there. Just before we finish up, just a short.
Just very quickly, let's talk about cost for a while. LafargeHolcim here, while I was working with Aldar in Abu Dhabi, we asked him to come in to give us some ideas about what Chris mentioned, GGBS and fly ash to replace ordinary Portland cement. And they said the cost would be comparable, but they don't receive any requests for lower carbon concrete. Same story in Saudi. Last month I've asked for quotations. They said the price, different degrees of replacement of ordinary cement. They said between 10 and 40% extra. The problem I've seen is once the contractor see that you impose something to them, they'll not only take that addition, but put another premium for risk. How can we manage that to, maybe through incentives, what Gabriela was saying, but how can we manage that in a way that people see it as an advantage to use lower carbon concrete?
Tina, did you want to just take that?
Yeah, I think I'd like to. I think what we need to keep in mind is that there will be more and more carbon regulation coming in. Carbon regulation already, I think it was hinted to, the CBAM, which is basically exporting into the European Union, now will be taxed on carbon at the border. So that sort of carbon regulation is going to impact supply and demand. But the other thing is that we're going to have more and more carbon regulation on thresholds for our buildings, our new developments and our renovations. And that will be a carbon threshold and in France, for instance, it's already in place. It's a carbon threshold per square meter of developed area or renovated area. And that is going down. That threshold is starting at 590, and it's going down every 3 years. And once you hit that, this will become mainstream. No one will be able to get a permit to develop a new building with the sort of carbon that standard concrete Portland cement actually requires. And then I think we're going to start looking at economies of scale because the industry will have to follow suit. So I think where all of us were coming from earlier is that policy can really drive this in a big way, which is why I think with RICS, one of our rules is to advocate with governments so that this policy actually comes put into place.
It's a great, that's a great finishing point. So I'm just going to run down with the final question. If you'd been sitting in the taxi with Joe instead of me, what would you have said to him? Tina, I'm going to start with you.
I think I would have said, "Spot on, young man," and we're going to be right there with you. Maybe not with a placard in front of and shouting slogans, but we're going to be there lobbying behind the scenes. Advocacy can go a long way.
Absolutely, Gabriela. How about you?
I will say that I share his worries, and I will say to him that. First of all, I believe that knowledge, we need to have clear communication and not to put labels of green on things, to just say, oh, we're adopting the green option. We need number. I believe that the clients, the public, has the information available, is very capable to choose right. So I think we need to have policy also that to have clear information on things so people can choose. So I think part of that we need to be pushing to have clear. Things need to be clear and open to the general public, and we can then choose. People can have the right to choose what is there, and we need to be looking at alternatives. How else, and be very careful how we call things. We want numbers that are all calculated in the same way, and then people can choose.
That's a great point you've kept making this afternoon, actually. Fahd, how about you? What would you have said to him?
We're working on it.
Grabbed his placard and joined him?
I would tell him we're working on it. We've been working on it for a long time. Sustainability was a big thing for concrete 20 years ago. Then it died because nobody was ready to pay the extra or
Very good
to
point.
give it that push. Regulation in the UAE is working well to poke and to answer Nikki's question. When Dubai was looking at to regulate the use of cement replacements here, the industry went back to municipality and pushed back, and they said you're going to push the prices up, but the prices did not go up. The volumes made up for the difference in costing, and we learned quickly, so we were able to deliver very limited cost difference.
That's very
The same will happen in Saudi.
And Professor Adel, how about you?
Tell them that we in universities, we are working with the new innovation, which is safe and cost-effective, called sustainable concrete. And maybe in the future, we are working on 3D concrete. It is starting, and this will lower the cost, and it becomes more environmental friendly. So we need some kind of, you have to trust universities and the industry both together, because we are working together for your benefit.
Thank you. And finally, Chris.
Apart from saying I agree, totally do, I am part of that process amongst a team of people who are doing everything that we can within our sphere of influence, right? And what I would say to him is that, first of all, totally agree. Let's open up communication. Let's understand each other. And I say, I work for an organization that we just reach out and communicate. And I would say that we have managed to make the progress that we've made only because we've reached out and communicated on a two-way conversation on this learning curve. And therefore, said my friend Joe, join us in our journey. I'm more than happy just to kind of invite him to actually meet with us in a project, even be in the room, because we hear out everybody. And maybe when he understands the realities of what we're up against, then he can modify his message in a way that is with understanding and potentially even more constructive, so that collectively we're moving faster rather than from conflict.
Yeah, great. All of those answers are far better than the answer that I gave. But I think the big message here is really that the industry needs to take accountability for this problem, as does government. Panel, thank you very much. Fantastic. That was a fantastic session. And audience, thank you as well. Round of applause for you all.